Okay, so in this part of the module, we're going to take a look at coming up with the names and coming up with the chemical formulas of covalent compounds. So when naming covalent compounds, the first nonmetal in the formula is named by its element name. And then the second nonmetal is named with an IDE ending. And if you think about that, that's very similar to what we talked about in terms of ionic compounds, where you have a metal and a nonmetal. The metal would be known by its element name, and that was the first part of the formula. And the nonmetal would be named with an IDE ending. And those IDE ending names, like chloride and oxide and nitride and such like that, are going to be used here as well. However, the main difference is the following. In covalent compounds, in the names, prefixes are used in front of each name to indicate the number of atoms present of that element. And the reason why is because, as we'll talk a little bit about, you could have multiple covalent compounds that contain the same two elements. But for the most part, for ionic, especially the ones that don't involve the transition elements, the metal and nonmetal can only really combine to give you one possible chemical compound, one possible chemical formula. That's not really true. That's not usually the case with covalent compounds. The same combination of nonmetals could usually lead to different covalent compounds. So the prefixes. So the prefixes that are used are the ones that basically for 1 through 10, and you have to commit these to sort of memory in a sense. So 1, mono, 2, di, 3, tri, 4, tetra, 5, penta, 6, hexa, 7, hecta, 8, octa, 9, nona, 10, deca. Now, the only time a prefix is not used is when there is one atom of the first element present. So the general idea is that prefixes are used in front of both names. The only exception to that is that if there's one atom of the first element that's present in the name, in the chemical formula, there's only the prefix mono is not used. But if you have one atom of the second element in the name of the chemical formula, then the prefix mono is going to be used. Now, one other thing. Sorry about that. I'm going to put some A's and one O in parentheses with the following. If the name begins in a vowel, do not use letter in parentheses. Okay. So basically, it's all the A's, and then for mono, it's the O. So if the name begins in a vowel, do not use letter in parentheses. So for example, if you have 5 chlorines, you would write pentachloride because C is not a vowel. So we'll include the A in the pentachloride. On the other hand, if you have 5 oxygens, then in that case, you would just have pentoxide. Not pentaoxide, but pentoxide, okay? So just a little bit about those A's and when they're used and when they're not used. Okay, some examples. So naming covalent compounds. First one, NCl3, all right? So the first element is nitrogen. There's one atom of it. And the way I know that is because in the chemical formula, there's no subscript next to the N, so that means 1. And notice that because it's the first element and there's only one of it, I'm not going to use the prefix mono. So it's just nitrogen. And then Cl3, chloride, but because there's 3 of the chlorines, we would write trichloride. And therefore, the name of this covalent compound would be nitrogen trichloride. Right? Suppose we had to come up with a chemical formula, diboron trioxide. So diboron, boron, has the chemical symbol of B. Diboron means how many atoms of boron are there? There are 2. Okay. So of course that goes as a subscript next to the chemical symbol of the element. And then trioxide. Oxide, of course, represents oxygen. And the tri again represents how many atoms of oxygen are going to be present, 3. So the chemical formula for boron trioxide would be B2O3. A couple of examples. First one, we'll do a name, P4O6. So P, of course, is phosphorus. 4 atoms of it. The prefix for that is tetra. The first name we would have would be tetraphosphorus. Notice that I included the A in the tetra because P is not a vowel. And then 6 oxygens, O6, would be hex oxide. Not hexa oxide, hex oxide. Sorry about that. So tetraphosphorus hex oxide. And then, so that would be the name, tetraphosphorus hexoxide. And then the one underneath, sulfur dibromide. So sulfur, chemical symbol of S, there's no prefix in the sulfur, okay? So that means essentially there's 1 atom of it. Wouldn't put mono because it's the first element present. So that would give us 1 sulfur. And then dibromide, bromide of course represents bromine, chemical symbol of Br, and the di represents how many atoms of that would be present. You would have a chemical symbol of, you would have 2 atoms of it present. So sulfur dibromide, SBr2.